but definitely we cannot discuss them because of the time constraints. And we go on, and we know that business community needs to plan, the businesses need to plan their activities like the sales or client flows, and that depends on multiple parameters like how the traffic flows behave. It all depends on the weather patterns and emotional moods of clients. Boris Rabinovich from Sber, the Chief Data Officer, will tell us how all that can be attained with the confidential computing. Boris, over to you. Good afternoon, dear data scientists. Warm greetings from the CDO vertical, the adjacent vertical, the CDO of our bank, and I definitely am entrusted with interacting with the CDO community of ours, and I'll tell you a word about the main problem, the main issue that we face while working. Confidential computing issue is the topic of my today's intervention. To study something, you need to have data. When you work at a bank and you have lots of personal data, the banking secrecy comes to the fore, so you should know what are the risks and what are the boundaries. We are not alone here, definitely. It's not only about the bank's operation, but you also need to exchange with other industries and sectors. And how can that be done? How can models be trained with such data? Can you use data from different industries without breaching legislation? And definitely we face this issue also. I'll tell you about several types of confidential computing, and we invest our R&D resources. I'll tell you about homomorphic encryption and several algorithms that we tested, data synthesis and hardware solutions. I will not tell you about depersonalization. All the methods of depersonalizing have been broadly applied, and we definitely coordinate with the regulators so that we have a go-ahead to work with the depersonalized data of huge categories of users. And then comes the differential privacy that is still fledgling. Currently, this method would not provide the necessary accuracy that our data scientists need with respect to the output data. So I'll tell you how we resolve all that. We want to come up with a data set that will store and maintain all the initial characteristics of data to be used for training. And we use different methods of depersonalizing. Let's start with homomorphic encryption. It is a very interesting technology. It is a pioneering sector, a pioneering solution. Where we end up, we have a number of algorithms about homomorphic encryption, and we applied them, and the data owner on their side hashes data and sends data to a cloud or wherever. On top of that hash, you can perform algebra operations. You can merge data between different data sets from partners. You can design and elaborate a model and send it back to the owner and decache that. And at the end of the day, you'll have the result that you expect. It seems to be a very good story, but it is fraught with a lot of costs. And each case is specific. It's not about that you can take one data set and hash it, and it is kind of quite sensitive to the final specific goal. We haven't been able to engage GPU, lack of Russian libraries, another constraint. With respect to the pace and speed, we used and tried TenSeal on an open source. We looked at the ischemic heart disease, collecting data over the past 10 years, and what we got was 600 times slowed down at the initial stage when we encrypted data, not model. And for a number of cases, the model may include some personal data, some secrecy, some private matters. And the second iteration was about hashing the model as well. In this case, we may have 100-fold deteriorations with respect to work on the depersonalized data with the same computing power, and definitely the accuracy stays also more or less the same. We have noted difference in the third character after the point. Had it not been for this dramatic slowdown, we would think of investing into it. I'll tell you about the conclusions later on. The second point
is data synthesis. So we're saying what it is. It is generated data set, which is maximally similar to the real one. How does it work? There are two approaches. The first one is a generation based on the real data set. We take input data set and start algorithms generating the similar data set, where you cannot find anything which would remind you or resemble real physical legal entities. The second approach is the generation of data set on a pre-trained data distribution model. Both have some peculiarities. In the first case, it is possible to get the exact data set with maximum similarity to the real one, but there are some limitations in place connected with the algorithms in place. They are not very good at working with the generation of the text with unstructured information. But in the second case, the accuracy is going to be lower, and you are really dependent on how you know the distribution model in advance. But what is good about all this approach? All these algorithms, this particular approach is certified by GDPR, by CCPA. But those organizations and those entities which can confirm these are the algorithms is the guarantee that you do not violate the law from the perspective of personal data protection. And of course, there are some conclusions. I do see this is a very interesting story which should be invested in. So let's go in detail what we are talking about, what kind of generation we are talking about. Synthetic data, particularly. Now we're looking at the example of classic depersonalization. We took the left data set, we launched this original data set, we took a cell phone, took a key, or killed, or changed the key, but the whole right side, pseudonymized data set, is like we had before. So what do we have as an outcome? There is a risk that on the data left, it is easy sometimes it is impossible, but in some cases it is possible to identify the original object. So this is a problem. How through the synthesis this problem should be solved is the following. The synthetic algorithms take the input original data and applying these algorithms to these data sets make a maximum similar data set, but in fact there is no single line where you can identify the original object. So how does it work particularly in real situation? The same cell phones numbers, but randomly changed. In the column of gender, you are going to have same number of female and male, but they're going to be at a random in a random order. As for the income distribution by combination of fields, matches initial data, but it's going to be a bit different. So as an outcome, you have the data set where you can train the model, but this is absolutely secure. There are a lot of players on the market. There are big vendor products, ready-to-use products, as mostly AI, some products which are bought by big companies. To have an opportunity to use these algorithms without any obstacles, there are some libraries, open source libraries, where we also test our algorithms as a result. So we had a very interesting experiment. We took a real synthetic data in a real life case. There is a response of the person in that to the call from the bank. We used AIJ boost. We took metrics. ROC metric was used for the quality estimation. The balanced learn is the open source library we used. We received around 2.53% increase. Mostly AI is a brand mostly popular in this story. Gave a very practical accuracy in the decimal point. This saying that we adopted these algorithms, the synthesis of data. We received the data set on the sets we required, and we provided for an opportunity our data scientists to work with these data sets without any obstacles. So this is the online mode. Everyone needs to have an opportunity to work remotely from home. When data scientist says that needs to create good models, but he has no opportunity to work in the remote mode with real data. This is a big problem, which used to be a serious obstacle, but which has been resolved. And the last story I'd like you to know is the encryption, hardware level encryption. There are several players on the market: Intel, NVIDIA, AMD. So what is the situation? There is an original data set. There is client software installed by a client who has the storage of the data. With the help of software, there is hashing procedure. The data is transferred to the major server, to the major engine, where there is specific hardware with the specific processors, where you can merge data from different sources. And applying the corresponding computation and the models, you can get the results and send the data back to the source. It seems. So what is the catch? Everything is quite comfortable. Everything can be used without any obstacles. There are some difficulties. The major difficulty is that you need to buy a specific hardware to this end. And this is investment in particular vendor. That's what we are afraid of. So what are the pros? In this particular case, this hardware by default guarantees that neither the operation system nor the major virtual machine have an opportunity to get access to the data and somehow to download open mode data from the CPU or GPU, unlike in the situation without this specific hardware. So we wouldn't be able to guarantee such security. What is great, what our outcome results demonstrate, that we have worked out together with our vendor, which is an Intel company, so we can guarantee that inside the system everything is secure and the speed is equal to the real computation. There is a low latency effect. So what are the fields of application? The first story is a real German bank applied these hardware-based computation certified by GPR, and it is compliant with GDPR. So against this system against money laundering. So all the data is processed and then sent to the destination point. The second one is the federated model training, where data never leaves the environment, and you cannot get the data from the destination device, where is a cell phone which has a model in place, a particular result on the cell phone is there, and it is sent as an aggregate mode to the higher layer, to the single mode, and there is a calibration of the model, the merging of data particularly, and therefore you get the more precise model using big data set with the higher accuracy without any violations. And so this story is applicable in one of the Spanish banks. And to conclude, like I said, that homomorphic encryption is very interesting area. So we calculated, we had computation, and we saw how it worked, but due to some obstacles in terms of the speed, it's not my priority. The second one is the synthetic data, very interesting story, quite competitive, but there are some limitations that it can be done only within the bank. These are not the algorithms which would allow you to send the data set somewhere outside the ecosystem of the bank to a particular company to have integration among many sources of data. And the last thing, hardware solution, which I just told you about, that's where we're moving, that's where we're looking at. Very interesting one, but it is just an infant state. We're going to see how it is going to develop in the future. Thank you very much for your attention, for the interest, and I'm ready to take your questions. So, Boris, thank you very much for a very interesting story, a short express session of QA. The question, which is a real trouble for many data scientists, how the technology influences the time of access to data, speed of operation with data, the average time of the access to data, whether it changes or not. So we're not talking about online mode, I'm talking about the algorithms which are applied at the moment of data preparation stage. At first, we prepare the data, we prepare the environment for the data scientists, and then they work in this environment without the lack or abundance of data in terms of the internal procedure of the bank. So it is much faster to get access to such data. You don't need to get the consent of the data owner, as there is nothing confidential. You can do with that whatever you want. So it increases access. And second question, which is top 2, are you planning to test the hardware-based confidential process methods? So now we're in the process, but we will demonstrate you some results when we are going to do some joint projects in the data association, big data association, and then we're going to test our hardware solutions. Thank you very much. Thank you very much, Boris, and all the best to you. Good luck.